Final question. So two packages A and B, each of 3 kilograms, are attached to the ends of a rope. Initially, A is held at rest on a smooth fixed plane that is inclined at alpha theta to the horizontal ground where sine theta is 2/7. The rope passes over a pulley P fixed at the top of a plane. The pulley is modeled as a small and smooth. The part of the string from AB is parallel to a line of greater slope of the plane. Package B hangs freely below P, as shown. The packages are released from rest with the string taut, and A moves up the plane. In this model, the packages are modeled as particles, and the rope is light and inextensible string. The magnitude of the tension in the string immediately after the packages are released is T newtons. Find the value of T. Okay, right. First of all, let's quickly just sort the sine theta out. So the sine theta is 2/7, so let's draw theta opposite hypotenuse. And so we've got here 49 minus 2, which 49 minus 4, root 45, which is 3 root 5. And so we can say quickly that cos theta is adjacent 3 root 5 over hypotenuse 7. Okay, so we've sorted the angle out. We already know that sine theta is 2/7, and we never really need tan. Alright, so let's label our forces now. So we've got the weight component, 3g, going down on this particle. We've got the reaction going here, and it's a smooth plane, so there's no friction, but there is a piece of string, so let's put a tension in here. And then you've got tension going on this side for particle B, and you've got a 3g weight component. So if I just have a look at particle A, that's going to accelerate up the plane, and particle B, look at particle B, that's going to accelerate downwards like that. Right, let's resolve for particle A. If we resolve parallel to the plane, you've got T going up the slope. What's coming down the slope? We've got the weight component coming down the slope. And so that's going to be 3g sine theta. And here you've got 3g cos theta. So you've got tension pulling it up the plane, and you've got 3g sine theta coming down the slope. And that's equal to MA, because that's resultant force, and because this is accelerating up the slope, that's going to be equal to MA. M is 3, acceleration. Right, and if I look at particle B, and I do my resultant force going down, so my resultant force is going to be, in the vertical plane, it's going to be 3g minus T, and again, that's equal to 3A. And so if I now, let's just sub some stuff in. So I know that sine theta was equal to 2/7. So from this equation over here, I can go with, okay, so T minus 3g times 2/7, so that's going to be 6/7 g equals 3a. The question is telling me to find T. So I probably don't want to eliminate T here. What I can do, by subtracting them, I can eliminate my A's. So I'm going to subtract these two equations. T minus T, that's going to give me 2T. I've got minus 6/7 g minus 3g. So that's 27 over 7 g. So we've got and that's going to be equal to 0. And so we can then say that T is equal to, move the 27 over 7g over, and then divided by 2, so 27 over 14g, and that works out as T is equal to 18.9 newtons. And then it says, at the instant when the packages are released from rest, B is 0.8 meters above the ground and A is at the point C on the plane. When B reaches the ground, B is immediately brought to rest by the impact with the ground. In the subsequent motion, A does not reach P and comes to instantaneous rest at D. Now we've got to find CD. So this is a multi-phase problem. So what's going to happen is that A is going to move up the slope while B moves vertically down. But when B hits the ground, A is going to carry on for a little bit, and then it's going to stop. And we're going to work out where it stops. So in the two phases, in phase one, let's work out. In phase one, we know that the distance traveled is 0.8. We know it starts from rest. We don't know our final velocity, but that will probably come in handy because it's a two-phase problem. We don't know our acceleration, but we could work it out. Remember, we worked out what tension is. We can sub the tension back in to work out our acceleration. And we don't know what time is, but that's probably not going to be relevant in this question. So taking the 27/14g as my tension, subbing it back into one of my equations, it doesn't matter which equation you sub it into, you can work out what acceleration is going to be. And so acceleration, I'll make that 3.5. And so acceleration is 3.5 meters per second squared. And I know that it started from rest. So I've got 3 bits of information, which would allow me to work out what V is. I can use, I don't want T, so V squared equals U squared plus 2AS. And so V squared is equal to 0 squared plus 2, 3.5 times 0.8. And so V is equal to the square root of 5.6. Now, that's the velocity with which B hits the ground. So that's the velocity with which A is moving up the slope. Now, in the next phase of the motion, the string is now slack. Because B has hit the ground, the string is going to be slack. And so there's going to be no tension in the string pulling particle A up. The only thing that's going to be acting on it is the weight component coming down the slope. And the weight component coming down the slope was 3g sine alpha. We know that from earlier. So we've got 3g sine alpha coming down the slope. So if I resolve for A, for particle A, let's just resolve down the slope this time because it's only got one force going down the slope. 3g sine theta is equal to 3a. And so A is equal to, I know that sine theta was 2/7, so A is equal to 2/7 g. And so that's the acceleration down the slope. So in the second phase, we know that the initial velocity is square root of 5.6 because the second phase starts immediately at the end of first phase. So the final velocity at the end of phase 1 is going to be the initial velocity at the start of phase 2. The final velocity this time, what's going to happen is that the particle's going to keep moving up the slope, but eventually it's going to slow down and stop. So because it stops, the final velocity is 0. And the acceleration, we just worked that out as 2/7 g, but that was down the slope. And at the moment, I'm looking at up the slope. So this is going to be minus 2/7 g. And again, I'm not interested in the time for this question. So I can do V squared equals U squared plus 2s again. So V squared is equal to U squared plus 2AS. And if I rearrange all of that, I should get S as equal to 1. So S equals 1 is the distance it travels after B hits the ground. And so the total, and that's what we were asked to find. We were asked to find the total distance. So CD is therefore 0.8 because it moved 0.8 in the first phase. And in the second phase, it moved 1 meter So the total distance is 1.8 meters. The last part says, state two limitations of the model that could affect the reliability of your answers. Well, we assumed that in this model we assumed that the plane was smooth. It's very unlikely that you're going to find a fully smooth plane. So including friction would improve the reliability. We also used a smooth pulley, which is unlikely as well. So having the tension on either side of the pulley being the same, that's probably going to be unlikely as well. So that will improve our answers if you factored that tension was slightly different on either side. So you can these are your go-to answers when we get questions like this. You just need to learn what the different limitations are of each model, and then just remember to write them in. Yeah.